Hello friends, welcome to this lecture of information theory. In this lecture, I am going to discuss the various properties of entropy. There are particularly two properties discussed under the concept of entropy, and these are number one, extremal property, and number two, extension property. Extremal property says that if the source generated m symbols, then the entropy would be log 2 of m. So we can just use this property to solve the questions like that. Suppose the question is, what would be the maximum entropy for when all the events are equiprobable. So the idea is that when the probability of occurrence of all the events are equal, suppose it is m by 1 by m. So what would be the entropy? We have to find out the entropy of xi. So we can find it by using the simple fact that log of pxi. Fine? Log of, it is basically summation of pxi log 1 by pxi. Fine? So this is probability is 1 by m, 1 into log 1 by m1, 1 by m2, log 1 by m2, and so on, m by n. All are with the same probability. Fine? All are with the same probability. So log 1 by m. Fine? So what would be the outcome? The outcome would be that we can see that there are m events, that we can write it as 1 by m into 1 by m log 1 by m. Fine? So this would be cancel out, and the answer that we obtain would be log 1 by m or log 2 m. Fine? So the fact that for this property is that, fine, we can obtain this relation. So we can obtain this relation only when all the events are equiprobable. When all the events are equiprobable. But when we look at the extension property, it says that if the source generate S is equal to x1, x2, x3, xn, that is all with the different all different events with different probability, then the entropy would be given. It would be as h x raised to power n is equal to n into hx. Fine? And how we can solve the problem using this property? Let us check that. Suppose we have the event, consider a set of events, with probability of occurrence as px1 1 by 2, px2 1 by 4, and px3 1 by 8. So compute entropy for it. So how we can compute the entropy for it? Let us check that. Fine? So we have to compute the entropy as Hx and Hx5. Fine, Hx5. The question would be given as something like that. Fine. So let us first determine Hx. So in order to determine the Hx, we can write this as 1 by 2 log 2, then plus 1 by 4 log 4 plus 1 by 2 log, this is basically 1 by 2. Would be 1 by 2. This is okay. This is difference of. This is difference of 1 by 2. This is 1 by 4. This is 1 by 8 log 1 by 5. So what we can do here, that we can simply determine it. We can take this particular sign inside it, and we obtain each expression in this way: 1 by 4 log 1 by 4, 1 by 8 log 1 by 8. Fine. So I am solving this thing here. So what we can obtain the Hx then? We can obtain Hx then, that this would become, this expression would become 1 by 2. If I remove this sign, then the expression would become log 2. Fine, log 2. Then 1 by 4 log 4, 1 by 8 log 8. So the answer would be, this is entire would become 1. This entire 2 raised to power 2. Fine. So this would become 2 because it is equal to 1. This would become 1 by 8. It would become 3. Fine. Fine. So it would become 2. It would become 2. So how we are obtaining this? You can understand this, that log 2 can be, this 4 can be represented as 2 raised to power 2, and this entire I can write it as 2 log 2 raised to power 2, and this entire becomes 1. So 2 into 1 is equal to 2. Fine. Similarly, I can obtain this thing as 3. So now we are in position to solve this question. So we can find out the question. This is 2, 4, 4, 2. This is 4. This is 3, and this is nothing but 11 by 8. Fine. So the answer is 11 by 8. But this is only for the Hx. We have obtained the answer for the Hx, but we have to find out the value of x raised to the power 5. So how we can solve it? We can use this property, the idea of this property. So using this property, how I can solve this question? So we have obtained Hx as 11 by 8, and using the property Hx5, we can write it as 5 Hx. That means it is nothing, 5 into 11 by 8, that is 55 by 8. So this is our answer. So this is all about from this lecture of the properties of entropy.